Okay, just now we calculate that we have obtained the minimum inductor value for CCM condition for 12 volt. Input is 14.79 microhenry. Meanwhile, for 18 volt input, the minimum inductor should be placed on this component, this system is 22.28 microhenry. So this is the value for 18 volt. Let's say for 12 volt, this is the value. Okay, then we take a look at what are the actual for normal practice for our system. Let's say we want to put into the circuit. It is usually that we increase another 25% in terms of value that we calculate. We increase another 25% to make sure that the system is to be operated under CCM at all time. So this means that we increase another 25% in terms of range. We can increase further, but it will incur in terms of cost. So when you increase further, means that you incur more costs, so the profit for your company will be reduced. So 25% is a normal range of increment that we perform within company decision. Okay, for 12 volt condition, the L-min is 90 microhenry. Meanwhile, for 18 volt, the L-min inductor value minimum is 28 microhenry. Okay, next we calculate for C, the component to regulate the voltage output of our system. So for C, for normal practice, for inductor we increase 25%. C in terms of regulation, in terms of our output voltage, if not being mentioned, so we set at 1% of output regulation of delta V0 divided by average voltage, output voltage. So C is equal to D divided by R divided by delta V0 of V times F. So for this 12 volt duty cycle, we shall obtain our required C value of 37 microfarad. Meanwhile, for 18 volt, the required capacitor value is 30.33 microfarad. So we have two values now. Is that the condition is on the 12 volt and 18 volt. We cannot use or apply both values at the same circuit. So we need to choose. So we need to choose between the value that we calculate for 18 volt or 12 volt. So which one to be implemented into our inductor and capacitor here. So for normal practice, we shall select the most highest value. Means that the higher the value we put in, so the better the regulation will be. So we cannot select 30, because when we select 30, when the condition of 12 volt happen, so the capacitor value is not sufficient to support in terms of the output voltage regulation. And for inductor point of view, so between 14 and 22 microhenry here, so this should be selected because this will support as well as 12 volt operating condition. So 22.28. So we move into the next and highest value of 23 microhenry. So not should be exactly at 22.28, but around 23 microhenry is sufficient for our system. So 23 microhenry for inductor, 37, maybe 37 is not available in market, so we can select for 40, let's say, microfarad, which is next highest available in the catalog. Okay, that's all for question number 7. Okay, next question number 9, which is the same as question number 6.28 in our textbook. So we need to design a buck boost converter that has a source which can vary from 10 to 14 volt, output regulated at negative 12 volt, the load varies from 10 to 15 watt, means that our resistor here is regulated, adjustable from certain value to certain value to comply the 10 to 15 watt of load. So we transfer all the data into circuit, input of 10 to 14 volt. So we don't have yet the frequency. We have the output voltage, negative 12 volt here. And in terms of range of our output power from 10 to 15 watt. And given here is the required regulation of our output voltage, which is less than 1%. So what are the other assumption for our design in terms of inductor, capacitor, and we should explain our circuit and what kind of condition it operates. So we should assume that this circuit or system to be operated under CCM with 25% later in terms of their values of inductor to be increased instead of our calculated minimum inductor current later. And the other component is assumed as ideal components. So the first thing that we need to calculate or find out is the duty cycle. So we have two conditions here, 10 and 14 volt. So both will have a different duty cycle to respond to the load. So we calculate both conditions. So we have at input current a voltage of 10 volt. So how much the D? So 10 equal for 10 volt, V out equal to negative Vs times D divided by 1 minus D. So we shall get the duty cycle of 0.545. So at V in of 14 volt, we shall calculate, and the output of D is equal to 0.461. So the range actually of our control duty cycle should be between this 461 to 0.545 duty cycle. So this is the range of our control for D, for our system. So next, okay, then we shall include or use this duty cycle range that we have calculated into our scenario of the output range, which is varies between 10 to 15 watt. So we have to calculate upfront in terms of at 10 watts, what are the value of resistor happen here at our load, and at 15 watt, what are effective resistance value at our 12 volt load here. So we use the normal power equation, P equal to V squared over R. So for R we can get from V output voltage here squared divided by P. So for 10 watts, 12 squared. So 12 squared times divided by 10. So we get 14.4 ohm. For 15 watt is 12 squared divided by 15. So 12 volt divided by 15 watts. 12 volt divided by 10 watts. 14.4 ohm and 9.6 ohm. So we use these two resistor value to find out the inductor minimum inductor value minimum that we require for the system to operate under CCM at 10 watt and at 15 watt. So at 10 watt of 10 ohm, so we have 1 minus D squared times R divided by 2F. So 1 minus 0.457 squared times 14.4. So we assume, because this switching circuit, we haven't been indicated inside the question, and assumption can be made. You can use 50 kilohertz, 100 kilohertz, 30 kilohertz. So the range is between 20 kilohertz up to maybe up to 500 kilohertz. Cannot use more than that, because when our switching in terms of power switching, so we will make more losses on higher frequency switching. If you use below 20 kilohertz, so you will introduce audible noise issue. So we just put here 100 kilohertz as our justification value. So 2 times 100. So 2 times 100k, we shall get 14.9 microhenry. While for 10 watt at 14 volt, L min calculated to be 20.9 microhenry. So this is the two values that we calculate in terms of their range, such that at 10 watt 10 volt, this is the required value. 10 watt 14 volt, this is the required value. Okay, next for 15 watt condition. 15 watt at 10 or 10 volt of incoming. So what are the range of minimum inductor value that required for the circuit to maintain CCM? So we use a duty cycle of 0.454 squared, 1 minus 4.454 squared, times 9.6 of 15 ohm, 15 watt resistance, divide by 2 times the frequency, so we get 9.94 microhenry. So at 15 watt 14 volt incoming, the L min calculated to be 13.94 microhenry. So we have 4 values here now. We have 4 values here. So actually, which one you should use as your, sign values? Is it this one, this one, or this one? So means that in terms of L min, for all condition, only this one can fulfill the criteria of CCM. Means that if you choose this one, if at this condition happen, so the inductance will not be sufficient. But if you choose this one, so it will comply all other conditions. Means that the biggest value is preferable to maintain or ensure that at all conditions the system or the circuit will operate at CCM. So for this value that we have calculated just now of 20.94 microhenry times 1.25, because we need to increase another 25%, so we shall get 26 microhenry of the inductor value to be assigned at our circuit, 26 microhenry. So the point not should be put in because just put initial value of 26 microhenry. So for inductor value, C is equal to D divided by R times the range of the delta V naught or V, filter range, and times F. So in actual condition or case, we need to find the highest capacitor value, same per our inductor now. So to get the highest capacitor value, which can cater all the condition that happen within our scenario of 10 or 14 volt, 10 12 or 10 or 14 volt incoming, 10 or 15 watts. So we should obtain the highest possible C. So get highest C, so we should aim for the highest D and the lowest R. So the highest D and lowest R. So 0.454 of duty cycle, the minimum, the lowest resistor is 9.6. The value of voltage range is determined already, 1%, and our frequency is 100 kilohertz. So when we calculate, we get 568 microfarad of the required capacitor value, or we can round up to 600 microfarad, which is available in the market. So this is our values or component decision and our assumption of our system for this question. Okay. So that's all for the tutorial. We have discussed buck boost and buck boost. So if you have any question, you can privately WhatsApp me, or we can discuss further for any things that still unclear on this tutorial. Thank you very much for your time. Good luck.